Hello everyone, let us see about eccentric loading today. Before going into eccentric loading, let us see the three types of stresses. The first one, direct stress, the second one, bending stress, and the last one, shear stress. So a direct stress is a stress that will act on a member when the load acts along the axis of the member. It may be either compressive or tensile. A direct stress is found using the formula load per unit area. Bending stress is when the material's load acts perpendicular to the axis of the body. So it causes both tensile and compressive nature on either side of the material. The bending stress is found using the formula sigma equal to m by z, which is simplified from the bending moment equation. Now the third type of stress is here shear stress. So when a member is subjected to a twisting moment, it experiences shear stress, and also when a member subjected to a shear force also experience shear stress. Now the formula for shear stress when the member is subjected to a torque is T into R by J. And if it is a member subjected to shear force, the formula for shear stress is shear force per resisting area. Now let us go into the eccentric load. Now when a load acts parallel to the axis, somewhat it will resemble a tensile or a compressive force. But when it is away from the axis at a distance, it contributes to eccentric loading. So load acting at a distance from the axis parallel to the axis forms eccentric loading condition. How to solve this? So this is what is quite important. Now the net force acting here is P downwards. Now this system is equivalent to a system where we have added two equal and opposite forces along the axis of the member for simplicity. Again here the net force acting is unaltered and it is P acting downwards. So it is an equivalent system which produces the same effect. Now this equivalent system is equal to sum of two systems. The first one is a member with a direct stress, which is either compressive or tensile. Now the stress is found using the direct stress formula, load by area, where area is the cross-sectional area which resists this direct loading. Now the another system that is going to be added here is a system with the other two forces, a force which is acting downwards and upwards, which forms a couple. Now this creates a bending stress nature. So the stress magnitude is found using the bending stress formula, and it is tensile on one side and compressive on the other side. Now the total stress is the combination of these two systems. So the total stress is found using adding the same nature stress on one side. So for example, it will be compressive or tensile and tensile. And the other side, we have to find the difference as it will be the two different nature, and we have to take the nature of the largest stress. It may be either compressive or tensile. This is how the total stress acting on the member will be found out. Thank you. Happy learning.